Welcome back, everyone. In this lesson and the next one, we're going to take a look at the idea of using databases. Now, what I like to do in this one is to create a database. I call it a student database, which is a very simple database just to keep track of a class, the students in it, the student's ID, name, email, and grade. For this first one, we're going to use basically the file system, a text file, to keep track of the student record. So you see how you can read and write to files. We've done that, but we're going to see it in practice again. And I'm going to highlight some of the issues when you're dealing with just the file system. In the next lesson, we are going to introduce SQLite, which comes built in with Python. It's native to Python. It's a very popular database. If you have an iPhone or an Android device, all the applications on those, almost all of them use exclusively SQLite databases. Very powerful, very small database. Later on in these series, I will introduce Postgres, if you're familiar with Postgres database management system, and how Python can connect to that too. Of course, you can have Python connect to SQL Server, to Oracle, to any of them. It has drivers for all of them or connections for all of them. But for now, we'll take a look at the file system, SQLite, which is native, and later on, at some point, I'm going to introduce Postgres as well. Let's get going. The first thing we're going to do is to import the system, and then I decided to have a student class created for student objects. As you can see, I've got my function _init _. I showed earlier in the series the so-called dunder methods, and these are the dunder method. Init is an example of a dunder method. In fact, if you go back to lesson 15.015, you can see more about it. But this is required. This is the Python constructor. So we use the self keyword to reference to the object itself, and I have 4 variables to identify, or 4 attributes, if you will, to identify a student. An identity, a name, email, and a grade, which if it's not passed, I'm assuming a grade of 0. So you can see that I'm making grade be an integer. I actually assume that identity is an integer in this as well. Name and email are, of course, strings. Remember, in Python, whatever is on the right-hand side gets assigned to what's on the left-hand side. So although this says self.identity, this is an internal variable to the class. This is not. This is what we're passing. In other words, I could make this be INEG and make this INEG, and keep this as identity, name, email, grade, and it will work just as well. But Python can keep track of it for us because this is not really identity over here. This is self.identity. This is the internal variable to the class, so the internal attribute of the object. I do have a couple of methods. I have one called fetchStudent, which doesn't take any parameters other than self, and it creates a tuple by taking these 4 attributes and then returns that. And then I have a method called setGrade, which takes a grade that gets passed. And notice in this case I just put G. I could put grade if I wanted to, just like I did up here, but I decided to just be different. So this takes a grade and assigns it to the internal grade of the object. For this, I decided to create a little menu. So we have a menu, a print statement for blank space, main menu shows up, another print statement for another blank space, and we have 6 options: print roster, fetch a student by ID, change a student grade by ID, assign grades to everyone, drop a student from class, add a student to class, and finally queue to quit the program. Why not 7? Well, I figured maybe I want to add additional options later, so I can have 7, 8, 9. So I just made this one queue. So this is our main menu that will show up, and for each of these, what I did was to develop a function, which we'll take a look at. But first, let's go ahead and take a look at the main method, which is what gets called. So here's the main method main. We're going to greet them by welcome to the student database, and then I'm going to ask them to type in a class name and an instructor name. Now for this particular program, the instructor name doesn't play any role whatsoever. I do have a graphical version of this that I have developed, which I might include later in these series, And for that, I had to use the instructor name. So I just decided to keep it there. Next, what I do is I create a file, name variable, and I take the class name and I replace the spaces with nothing. And I also append the .txt extension to it. So this file name is going to be basically my database, my text file database. I also have an empty list that I create out called storage. The idea here is that the student objects that we create will be kept in memory in this list, and when the program ends, it's going to write everything that's in storage into this file name. When the program starts, it's going to read back the information from this file name and populate the list, the storage list right here. So I get started by first creating an in-file variable and saying open this file name. If it's there, of course, I'm going to read it for reading purposes. And for each line in this file, I'm going to read all the lines initially, in-file.read lines, and I'm going to loop through each line. I'm going to split those lines based on the comma, and then I'm going to assign the first element of that. This is going to be a list. First element, which is the ID, I'm going to convert it to an integer to the student ID. The next one to student name, student email, grade. I'm going to replace the line break with nothing here and assign it to grade. And notice over here, I'm going to create a new student object by calling the student constructor and pass to it these things. And then I'm going to add this new student object by appending it to this storage, to the list. After all the items in the loop have been looped through the files, then I'm going to close that file. Now, this is a try except clause, which is for error handling here. And I want to point out to you that if there is no file to read from, this is going to throw an error message here. Well, the exception clause is going to catch that exception, and then it's going to do nothing. It's just going to say move right along. It's not a problem. I've discussed error handling more in lesson 19.019. You can take a look at that. So this is the first thing we do. Now, of course, the very first time we run this program, we don't have any files. So let's see what's going to happen. This is going to simply say pass. It's going to come over here, create this variable selection, which is nothing. And then I'm going to do a loop while selection is not equal to Q. So they haven't selected the quit option. I'm going to display the menu. I call that menu function. I'm going to ask him to make a selection. And I'm going to accept that input. Then I have this variable response created, which is going to call a function which we're going to look at, which is going to take the selection they put in, 1 through 6 or Q, and also pass to it this empty list. Initially, it's empty. Of course, over here, I check to see if the response is Q, then I will break, but we'll get to this in just a moment. Let's see what happens when we call process request. So process request is right here, and it takes the selection they made and the storage, which is an empty list, and I simply checked. If they picked 1, I call a function called print roster, which it needs the storage to work with. If they select 2, then I call a function fetch student by ID. Kind of makes sense because that's option 2, fetch student by ID. If they select 3, then I call change grade by ID. If they select 4, assign grades. That's to everybody. If they select 5, I'm going to drop the student from class. And if they select 6, I'm going to add the student. Now notice that if they select anything other than 1 through 6, even if they don't select Q, I'm saying else. So else, I'm going to return Q to the calling program. So for all of these, we're not going to return anything. We're just going to call a function. But if they enter anything other than 1 through 6, if they press Q or 7 or 9 or anything else, Q is returned to this response. This becomes Q, and if response is equal to Q, then we're going to basically break the program. We're going to stop at this point. So what happens when they call, if they select 1? Well, I call print roster. This is very easy to do. Look at print roster, and we're going to create a little header, and then we're going to loop through all the elements in the list for S, representing a student. In storage, I'm simply going to call the fetch student method of this object. The fetch student method simply returns a tuple, and that gets displayed. So I'm going to basically loop through and print each of these. If they select 2, I do fetch student by ID. Well, this requires a little bit of a search. So I first ask him to enter student ID, and I cast it into an integer because student IDs are integers. I create a variable found equals false, and then I loop through the storage. I call fetch student, which, as you recall, returns this tuple. So this is element 0, 1, 2, and 3. I check to see if element 0 is equal to the student ID that they entered. If they did, I basically print that student, which is what they wanted, fetch a student by ID. I send found equals to true, and I break out of the loop. Outside of the loop, we check if found is equal to false, then we're going to print no student by that ID. If it was set to true, then this doesn't execute, and we're good to go. So that takes care of fetch student by ID. Changing a grade by ID, we simply ask for a student's ID again, as before found equals false. I loop through the storage again, and if I find a student that matches, I print a student so they can see which student's grade they're changing. I have a numeric grade variable created which accepts a numeric grade from the screen. Of course, I'm assuming they're going to be well behaved and not typing ABCD. Once I get that grade, I'm going to call the setGrade method of the student that I found and pass it the numeric grade. So the setGrade method is called, and we're going to assign that to the internal student object. We set found equals true, and we break again as before. If we loop through the whole thing and not find anything, then found it remains false. We do a double equality comparison check, and we're going to tell them no student by that ID. So that's very easy. For assigning grades to everyone, it's even easier than that. We don't need to find anyone. We just need to loop through the storage array, or storage list, I should say. Print every student so they can see the student, ask for a numeric grade, call setGrade, numeric grade, assign the grade, and we're good to go. To drop a student, very easy. Again, we want to ask him for a student ID. Again, we want to find that student. So at this point, you probably say, well, listen, you're going to do this search all the time. Shouldn't this be a function by itself? And you're absolutely correct. In the database one, the one we use database with, I do turn this into a search function. But for now, we're going to again search through and see if for each object in each student object in this list, if when you fetch it and compare the ID, which is the 0th element or 0th index, is equal to the student ID that they typed in. If that's the case, found is true. I print the student, and then I'm going to have a confirm variable that I've created. I'm going to ask him, are you sure you want to drop this student? Type Y or N for yes or no. If they type yes, and notice I'm saying confirm.lower, so in case they type in an uppercase Y, we're still going to accept that. We're going to convert them regardless of what they type to lowercase. If it's equal to this, we simply call the remove method of a list and remove that student. Print student dropped, break out of the loop. We're good to go. If this is not equal to Y, then we're going to tell them operation cancel, but we're still going to break out of the loop. Of course, it's possible we loop through this whole thing and never find a student with the ID they asked or they put in. So then found is going to remain false. So if that's the case, again, we're going to say no student by that ID. Lastly, we have add student, which is going to allow us to add students. We're going to ask them to input some students with an ID that's 4 digits, a name and an email. Of course, there are currently no grades because when you first enroll students, they don't have a grade. And that's fine. We're going to use the new student variable here. We're going to call the student constructor, pass to it these. And notice that because we're not passing in the grade by default is going to assume to be 0. So we don't need to pass the grade in. That being the case, we're going to append that to this list, storage that we have, storage.append. We're going to add that and let them know that the student was added successfully. So all this fine and dandy, all this happens up there. When we quit the program properly, so assuming that they do Q, we break out of this loop, but the program hasn't ended. It's going to come over here. So over here, I have a file, a handle called out file, and I'm going to open the file name that we created. I'm going to open that for writing purposes. And then I'm simply going to loop through the storage list. and I'm going to print to the file. Notice that I'm printing the ID file out file, so it's going to write it to this out file, and I'm going to end it with a comma. So it's going to put the ID and then a comma, and then it's going to print on the same line the name, which is index 1, put another comma, then it's going to print the email, put another comma, then it's going to print the grade. After the grade, it's going to put a line break. So that's basically for the first student, and then the second student is going to start printing to the next line, so on and so forth. We close the file, and we're good to go. Over here, I'm simply calling main, just so you know. And just so you understand the replace function, I have this simple example here. This is a piece of text. You can see there are spaces in here, and I want to replace the spaces with nothing. Let's see what happens, and also add a .txt. You can see that it became, this is a piece of text.txt. Now over here I have an example. For instance, in the text file I would have 1, 2, 3, 4 Bugs Bunny bbunny@gw.edu, and then the grade of 0. When I split, based on that, when I'm reading this stuff back, as you recall here, I'm using the split method. To split, it's going to create a list. So take a look. So it creates a list that puts these items in the list based on the split on that comma. So I have 1, 2, 3 for Bugs Bunny bbunny@gw.edu 0. This way I can address each element easily, which is what I did over here. So this is a list. Temp 0 is the ID. Temp 1 is the name. Temp 2 is the email, and temp 3 is the grade. Because the ID and the grade are integers, I'm also casting them into integers over here. Very easy. You notice that in this case I don't have a line break here, but if I had a line break, all I'm doing here is I'm replacing that line break with nothing, so the grade doesn't have a line break. Let's check out this file. I'm going to shift enter it, and it comes up saying what is the class name. Let me call it, Python 101, and press enter. Instructor is Dr. Z, and then it gives the main menu. I wish this Safari stuff wouldn't come up, but it does. So make a selection. If I print roster, you notice that the print roster, of course, is not going to print anything because it's empty right now. So let's go ahead and add some students. I'm going to select option 6 here. And I'm going to add 1, 2, 3, 4 for the ID, and let's say it is in fact Bugs Bunny. Email is bbunny@python.edu, and student was added successfully. Well, let's see if it was. I'm going to press 1, and I can see that it does print a class roster. Let's add another student. Option 6. 2, 3, 4, 5, and we're going to add, let's say, Daffy Duck, and dduck@python.edu, and student was added. I'm going to do number 1, I'm sorry, to see the roster. I'm going to quit this program properly by typing Q, and if everything worked fine, there should be a text file that's created. And this text file is going to be what I called it up here when I first started it. I called it, I think, Python 101. So if I run this again and type in Python 101, and the instructor doesn't matter. If I print roster, everything should still be there, and you can see that in fact it is there. It is writing to the text file. Here's the text file itself. As you can see, it's writing everything into that text file as we expected, with commas in the middle. Let me go ahead and close that. I'm going to now try the other things, such as changing the student grade by ID. So let me try number 3 here. And I'll type in 2, 3, 4, 5, and it's Daffy, and it shows Daffy, and I want to give Daffy an 88. If I print the roster, you can see that Daffy's grade was in fact changed to 88. Let's try assign grades to everyone, and this is going to loop through. It's going to show Bugs Bunny. I'll give Bugs Bunny a 98. And I was giving Daffy, I'll give Daffy a 78. And if I do 1, you can see that those grades were in fact changed. If I wanted to, I could drop a student from class. So let me go ahead and try to drop Bugs Bunny. So I'm going to select option 5. What's the student's ID? What if the student's ID is not there, like this when it says no student by that ID? Let me try option 5 and try 1, 2, 3, 4. It shows Bugs Bunny and it says, are you sure you want to drop this student? I'm going to say yes. And it says student dropped. And if I do 1, I can see that it's only now Daffy Duck. Now it's very important that we quit the program properly, otherwise it doesn't delete it from the file. So I'm going to Q to quit the program properly. And if I were to run this program again and type in Python 101, which is my course, and do print roster, only Daffy Duck shows up. I can also bring up the text file again. Let me just bring it up here so you guys can see it. And you see that it is only in fact Daffy that remains there. So this is, let me go ahead and quit this program. So this is certainly works, but it's fairly clumsy to have to handle files or keep track of things using a text file. There's nothing wrong with it. It was done for many years. Even today, in some instances, it may be preferable to do it if it's a small enough data to keep track of, such as for, say, initialization files, configuration files, etc. But generally speaking, we want to use a database. And in the next lesson, we will use SQLite database to see how it works. I hope you enjoyed this. If you're enjoying these videos, please share them with loved ones and friends. Thank you for being a great audience. See you in the next video.